All right, we're back. We're on page 72 of math analysis, and this is verifying identities. And we know the fundamental identities. There are 8 of those. You got your reciprocals, your ratios, you got your Pythagorean identities. The like undisputed champion of the Pythagorean is sine squared plus cosine squared equals 1. Find yourself using that all the time. It's also basically the equation of the unit circle, which is pretty handy. So now what I want to do is give you some strategies for how you can verify some identities, and we'll see what we can do from there. So the first strategy, and these are just from experience, like, I don't know, you just sit down and do like 80 or 100 of these at some point soon, hopefully, maybe spread that out over a lot of days, who knows. You will see the same things over and over again. And those are where these strategies came from. So the first strategy, I cannot stress enough, this strategy, make sure you copied the problem correctly. Not all things that you write down with an equal sign between them are going to be identities. Sometimes they're equations, but sometimes even then you don't get a solution. So make sure you wrote it correctly. And it's really common to accidentally take like the left-hand side from one problem, the right-hand side from another. It's a really common mistake. And the number of hours I've seen people just throw away because of that. So watch out for that. Now, the next strategy you won't really understand, I think, until you get going, but it is work on the more complicated side. So it's hard to tell which one is more complicated, I think. But generally speaking, is very, very generally speaking, it's easier to turn addition or subtract, sorry. It's easier to turn addition or subtraction into multiplication division, right? Because what you do is you get a common denominator, and in the process of that, you like multiply denominators. You just multiplied. You turn into kind of like multiplication. It's much easier to turn those two operations into the other two than the other way around. But again, it's not a hard, fast rule. Sometimes you do one, sometimes you do the other. So the next one is one where we can actually start doing something. So strategy number 3 here, break up fractions that have a sum or difference in the numerator, not the denominator, but in the numerator. So here is an identity that we want to verify. So what we're going to do is we're going to choose the more complicated side. I think it's pretty clear that the left-hand side is more complicated. It's got a numerator, a denominator, there's addition, there's multiplication, there's a lot going on. The right-hand side is just addition, like just addition. So I'm going to start on the left-hand side and try to turn it into the right-hand side. I'm never going to touch the right-hand side. So what I'm going to do is kind of like wall it off, right? I'm not going to touch this. So do not touch. That's just our goal. Our goal is to turn the left-hand side into that. That's a choice, though. We could have started on the right-hand side, and then our goal would be to turn the right-hand side into the left-hand side, and I would have highlighted the left-hand side and said, do not touch, because you just don't want to do that. So let's work only on the left-hand side, and we will break it up as suggested. So I'll say sine of x over sine x cosine x plus cosine of x over sine x cosine x equals, I'm not even going to write the right-hand side, because if you keep writing it, you will be tempted. If I don't write it, I'm not tempted. So I'm strictly working on the left-hand side, preferably working vertically. This is almost the only time where I work vertically instead of horizontally. I like to go across the page for some reason when I'm solving. Now this, I'm going to cancel those. I'm also going to cancel those. So I will get 1 over cosine plus 1 over sine. Well, this equals the right-hand side, which I'm not going to touch. 1 over cosine, because of the reciprocal identity, I know is secant. And 1 over sine, I know is cosecant, again, by the reciprocal identity. And then this equals the original thing we were given, cosecant plus secant, plus secant. So I managed to do it without ever crossing the equal sign. You never cross the equal sign. Don't do it. But the takeaway here is, because you see addition or subtraction in your numerator there, that's when you want to try this. So it's a good strategy. It works a lot. All of these strategies work, a lot. Otherwise, it wouldn't be strategies. Strategy number 4. Add, or I feel like I'm duplicating a color. I am, but do I need to duplicate a color? I might. Let me see, what color in my preferred palette have I not used yet? I think I didn't use this color. Yes. Okay. Strategy number 4. It's kind of basically the opposite, right? So the last strategy is if you see a sum or difference, break it up. This strategy is if you see fractions, try getting a common denominator. So like the exact opposite. So if you see 2 fractions, try combining them. If you see addition or subtraction in a fraction, try breaking it up. Try undoing what you did. So here the question is like, where are the fractions? Well, I know right away that tangent is sine over cosine. And I know that cotangent is cosine over sine. So I'm working on the left-hand side, and I'm not going to touch the right-hand side. So I'm just going to say equals. What does it equal? Secant times cosecant, but we'll get there. Now what I'm going to do is try combining, right? So I don't know, common denominator would be sine times cosine. So I'm going to get, I need to multiply this fraction by sine over sine. So I will get sine squared over sine x cosine x. Plus here, I need to multiply this fraction by cosine over cosine. So that's going to be cosine squared over sine x cosine x. And then sine squared plus cosine squared. And we're almost done. Depends on your outlook. I think you should write, you know, plenty of steps. Sine, cosine. So sine squared plus cosine squared, that's the one. That's the most famous one. That's 1. So now we have 1 over sine x cosine x. And what I'm going to do is I'm going to like show that I'm continuing this and get 1 over sine is cosecant. I always seem to get the 2 things in the opposite order, like kind of 1 over cosine is also secant, kind of regardless of how I approach the problem, which is kind of weird. I don't know. I mean, it's equivalent, so it doesn't make a difference. And there you go. We never had to touch the other side, whatever the other side is. Just never touch it. I'm actually just going to keep going because I think they're not like the most overwhelming things, so I don't think you need to pause and think that hard about it. But if you do, that's not a bad thing. I'm not trying to take that away from you. What color now? So do I have 6 colors that I like to use? I do. I have 7. There are actually 7 colors that I like to highlight with. So I should be able to do this. Oh no, 5. There's only 5 strategies on this page. We're great. Don't worry. All right. What is this strategy? So let's review them really quickly. Make sure you copy the problem correctly. That one should go without saying, but it needs to be said. Strategy 2, work on the complicated side, where experience will eventually tell you what's complicated. But also, if you just look at it, you're usually like, that looks more complicated than that. Like, it's not that hard. Break up a fraction if you can. Create a fraction if you can. So add and subtract. Get a common denominator is a common thing to do. If there's something to distribute, try distributing. So this is another one where, like, I bet the next one is if there's something you can factor, try factoring it. Let's actually see. Try to factor. Yep. That's the next video, though. Let's see if we can do this. So we want to verify this. Eventually, you will have this memorized, and you'll just use it. But for now, we're going to verify it. So I'm going to multiply this out. So I get 1 minus cosine squared equals something. All right, so now what am I going to do? Well, there's 2 options. I know that sine squared plus cosine squared equals 1. Now, since I know that, I'm going to do something that feels really weird. I am going to replace 1 with sine squared plus cosine squared. This is it's straight substitution. It's an incredibly useful substitution that I do kind of frequently. So I think that it's good to see it as soon as possible. So we're replacing sine at 1 with sine squared plus cosine squared, which is like, it feels like you're going in the wrong direction because things got bigger and longer. When things get longer, usually you are going in the wrong direction, but not in this case, because here I got cosine squared minus cosine squared. So I actually just have sine squared equals sine squared, which is what we were originally supposed to show it equal. And we are done. So that was by making a weird substitution, right? 1 is equal to sine squared plus cosine squared. You also potentially, I don't really like it as much in this particular problem, but since we do know that this is true, like you potentially also could just say, well, sine squared is 1 minus cosine squared, because that, we know that that is an identity. It's true for all values of x, and then just straight substitute 1 minus cosine squared is sine squared, which you should do. But I feel like the intention of this problem is for you to like do something a little different. But there's more, there's so many, there's like an infinite number of correct ways. There's also an infinite number of incorrect ways, but like as long as you're following the rules, you should be good. All right, what are we doing here? Verify this. There's nothing you're gonna do other than expand and hope for the best, really. So let's see what happens. Let's expand the first thing. So we're doing this. So that's gonna give me square the first. Multiply them together times 2. This one's like relatively famous. I don't know why. Well, I mean, because it works out cool. Square the last. All right, all of this is that green stuff. And then let's do this. And somehow it just equals 2, so that's fun. Plus square the first. Multiply them together times 2. And then square the last. And it's going to equal 2, but I'm not writing that because I don't want to like mess around on that side. So I have this. I guess I should continue my highlighting tradition here. All right, so what's going to happen? Well, if you look at these kind of closely, you'll notice plus 2 sine cosine minus 2 sine cosine. Those actually cancel. So we actually are getting, there's a sine squared and a sine squared. So we have 2 sine squared. And there's a cosine squared and a cosine squared, so plus 2 cosine squared. And then equals something, I'm not going to write it. And then take a 2 out. Sine squared plus cosine squared equals, then I know that sine squared plus sine squared plus cosine squared equals 1. That's going to be 2 times 1, which is 2, which equals 2, which was our goal. And we have done it. And we never cross the equal sign. So you're never going to cross an equal sign. That's not a strategy, that's a rule. And we don't cross the equal sign because what we're really doing is we're pretending we don't know the other side exists. And we're just like messing around. And then eventually we get this thing, we're like, oh my gosh, it's the other side. That's what we want to do, because in calculus, when you use these, you don't know what the other side is. You just know that the thing you currently have is like unusable. So if somebody asked me to graph the left-hand side of this, I would just graph the horizontal line y equals 2. And it would look crazy because like, how does all that become 2? But it does. So I will be back in the next video and we will keep going and I will see you there.